Launching a complex web application, like BITRIGID, means deploying high-stakes features like real-time WebSockets and local AI agents. For a solo founder, this venture operates under severe pressure: limited financial runway, a hard deadline, and an engineering scope that would normally require a full team. To survive, developers spend hours rigorously structuring their codebase to prevent logic errors. Yet they often treat their own biological brain like a chaotic, disorganized dumping ground. Solo operators rarely fail because their code breaks. They fail because their cognitive bandwidth fractures under the weight of constant context switching. To survive a modern tech launch, the founder has to engineer a parallel human architecture. They must protect their mental runway with the exact same rigor they apply to their software. The first layer of that human architecture controls the inputs. A developer has to vet the daily flood of API documentation and technical claims before that information pollutes the project. This framework outlines the SIFT method for lateral reading. Instead of judging a single page, you open tabs to see what independent sources say. Applying the investigate and find better coverage steps allows a founder to cross-reference a solution's credibility in minutes, avoiding deprecated libraries. Once secured, the founder must internalize those mechanics. This requires the Feynman Technique, breaking down a concept like WebSocket latency so simply a 12-year-old could understand. Industry jargon and unnecessary complexity often act as masks for a lack of understanding, a weakness that cannot survive the demand for a simple explanation. Filtering out bad data and demanding deep, simple comprehension prevents the mistake of building massive software infrastructure on top of flawed assumptions. Even with verified information, a biological brain cannot simultaneously hold API keys, UI frameworks, and marketing strategies without dropping threads. The solution is a second brain, an external, centralized digital repository built to expand your memory and intellect using modern search tools. The code methodology is a pipeline moving information through 4 stages: capture, organize, distill, and express. Incoming data is then sorted using the para method, categorized by actionability into 4 bins: short-term projects, long-term areas, future resources, or an archive. The Cornell method provides structure to feed this repository. The layout enforces clear separation: a left column for questions and a large right column for raw notes. It utilizes an immediate review process to write a summary at the bottom, catching early misunderstandings. Offloading this storage to a digital system clears the founder's mental RAM. That biological processing power is freed entirely for problem-solving and feature creation. With the cognitive load minimized, the founder can dedicate their focus to selecting software systems that require 0 manual upkeep. This means abandoning legacy testing tools like Selenium, which often require explicit waits and constant manual intervention, in favor of modern architectures. Selenium relies on an HTTP driver abstraction layer, while Playwright communicates directly with the browser through a persistent WebSocket connection. For a solo developer, Playwright offers massive advantages: auto-waiting for elements and executing tests concurrently across multiple browser contexts. Maintaining a stack requires a policy for what to stop doing, known as sunsetting. This Wikimedia strategy notes a lack of volunteers as the primary reason to shut down. By automating with Playwright, the founder sunsets manual testing, preventing operational collapse. Selecting Playwright isn't just a technical upgrade. It is a structural decision to eliminate manual maintenance and protect the founder's time. At peak efficiency, these 2 systems operate in tandem. Playwright runs automated tests flawlessly in the background, while the second brain instantly resurfaces the exact documentation needed to build the next feature. This parallel setup eliminates the constant friction and cognitive context switching that normally destroys a solo operator's focus. You cannot deploy highly resilient, complex code if the human operating system building it is fragmented and overwhelmed. A solo founder's ultimate competitive advantage is not the software they build, but the meticulous engineering of the mind that builds it.